So I'm Barry. I support the engineering team as a leader in London. It's my pleasure to welcome you to another one of our Tech Know-How events. Our goal at Expedia is delighted travellers, and how we do that is as important as what we do. Over the last 6 years or so that I've been here, we've evolved our technology stack significantly. We've gone from a classic three-tier model that when we released it, deployed it once a quarter, we had to shut down the site to do it, through to an MVC-based JVM web app, monolithic, which highly scalable but had some bottlenecks for it. Through to what we're doing now, which is cloud deployed microservices. But all of that with a relentless focus on the customer, focus on innovation, and shipping the stuff that we wanted to do, shipping our features, shipping our ideas quickly. So we've evolved our technology stack, but as importantly as that, we've evolved our technology culture as well. We've reinvigorated it over time. We are a truly global workforce. We've got an office in more than a dozen locations. We empower our engineers to choose the right technology for the job. They are free to choose the tools and choose the stack, choose the language that's appropriate to the job that they want to do. We encourage a rapid build hackathon culture because we want teams to have ideas, build them, and test them rapidly. And we also do events like this because we believe that we can learn from you and you can learn from us, and together we march off into a bright new future, a little happier and a little better informed. So anyway, that's enough from me. So I want to introduce David. David's going to give us some insights into how we build and how we broke our UI toolkit over time. So, David.
Thank you. Thank you, Barry. So, I'm David. I am dev lead here at Expedia London on the client-side engineering team. One of our biggest projects is the Expedia UI Toolkit. I'm going to talk a bit more about what that exactly is in a second. We're building, I've been about 4 years. During those 4 years, while building the UI Toolkit, I've learned about UI testing, and in particular, automated UI testing. So, I'm going to start off talking about what the Expedia UI Toolkit is, why it's so important to test it, and then I'll go into how we actually test it. So we're going to have a quick look at JavaScript unit tests to ensure our JavaScript is as good as it can be. We're going to look at functional testing to ensure any click or interaction a user makes works every time we do a release or every time we do a change. Then we look at visual regression testing. This allows us to ensure we don't make any unintended visual changes to the UI. And then finally, we're going to look at accessibility testing to try and make our website as
I'm Barry. I support the engineering team as a leader in London.
What is
my pleasure to welcome you.
Expedia UI Toolkit is a central repository of web components.
Our goal
the general rule is if a component is needed,
how we do that is as important as
then we'll include it in Expedia UI Toolkit.
Over the last 6
we
years
go back,
I've been here,
before I started, I've been here 4 years, so we go back to 5 and 6 years. They actually did a UX audit,
classic three-tier,
and they found about 28
released and deployed at once.
Every team had built their own in a slightly different way, with a slightly different design. And that kind of led to us doing
JVM web app, monolithic.
So we have about 30 different components, ranging from simple things like buttons, icons, all the way up to more complex interactive
cloud deployed
elements like data,
but all of that with a
media
relentless
galleries,
focus on the customer, focus on innovation, and shipping the stuff that we wanted to do.
They're used by the majority of ideas
quickly.
If you
So we evolved our technology stack
just
as
on our
important
homepage,
as that.
you'll see
technology culture as well. We've reinvigorated it over
They also
time.
used not just Expedia's site, but also other brands that we
fully
own.
mobile workforce with an
They'll
office
use
in
Orbitz,
more than a dozen
Travelocity.
locations. We encourage engineers
about
to choose
10 different
the right
brands
technology
we
for
own.
the job. They are free to choose the tool
It's used all over the
and
place.
choose.
This is really good because
choose
if
the
we
stack, choose the
improve
language,
performance of a component, or
choose the
we
job that they want
accessibility of a
to
component,
encourage
or even just
a
do a
rapid
slight
and
UX
rapid
change to make it more
culture,
useful,
because we want teams
then
to
all
have
these
ideas,
all these
build
users,
them,
all these teams
and
get it.
test them rapidly.
With
And
very minimal effort from their side.
we also do events like
We
this.
can roll out big
because we
changes
believe
really
that
quickly.
we
On the
work
flip side,
together
if we
and
break
work
something,
together,
then
we march
break
off into a bright new future.
which isn't good.
It's a little
So,
happier, a little better.
This is where testing comes in.
So, anyway, that's enough from me. So I want to introduce David. David's
We
going
go
to give us
back
some insights into how we build
when
and how we
this version
grow
of Toolkit.
our UI toolkit over time. So, David.
Thank you. Then we had a few Java unit tests, but in terms of the front end, we didn't really have any automated tests. I think back then, as a front-end developer, I don't think that was unusual. I think front-end developers, they much went in, they had a choice of doing a shiny new feature, or they had a choice of writing automated tests, and they generally went for a shiny new feature. That was either their choice, or it could have been the client going, I just want to see features, writing tests is going to take too long. So when we first started out, we did manual testing. Everything was manually tested across all our different browsers. It was quite laborious, it took a lot of time. And eventually we started to miss something. As the toolkit grew, it got more complex. Manually testing just wasn't an option anymore. So we had to rethink about how we did our testing. And that's where automated tests came into play. So first up, JavaScript unit tests. So I think as front-end developers, this is probably the most common type of test we write. So this is used to test individual JavaScript functions to ensure that they continue to work correctly over time as we make changes. So they're really good, they're really quick to run, so you can run them often. There's various frameworks to help you write them. So we use Jasmine within the client-side engineering team, but other teams in Expedia use different things, so QUnit is also very popular. And I don't know if anyone's using Mocha in Expedia, but it's another popular framework. So we're going to look at Jasmine today, just because that's what I'm most familiar with. So I'm going to start with an example. This isn't a test, this is a bit of JavaScript. Simple function, give it two numbers, it returns the sum of those numbers. So we haven't got any tests, so we're going to go manually test this function. How that used to look, we'd open the DevTools, we'd call the function, give it a couple of arguments, so it's like 5 and 6 and we get back 11, which is correct. Or if I add some strings to that instead of numbers, most people realise it actually returns 107, which isn't the sum of 10 and 7, so we've got an issue. So we can go back to our code, and we've got two choices. We can either say you're not allowed to add strings, and we can add some error checking there, or we can convert those strings into numbers. So I'm converting the strings into numbers. I'm now going to manually test again. First I need to check the first use case still works. So 5 and 6 still gives 11, which is good. And I'm going to check the new use case of 10 and 7, now gives 17. So we're all good. And this function could get more and more complex. We could add functionality to take as many numbers as you want. We could add validation to make sure you can't add letters into there. It can grow and grow over time and get more and more complex to test, and also more and more complex to remember what it should do. So it's harder to remember what you should actually be testing. And this is where unit testing really helps out. Now a quick look at Jasmine. So all Jasmine tests start off with this describe block. It's just JavaScript, so it's just a JavaScript function called describe. Saying describe, add the numbers. This it function which you call, so in this case say it should add together two integers. So it's very readable, whether you're technical or not technical, it's very readable, which is why I like Jasmine really. And then finally you do your actual test. So we've got, we expect add numbers 1 and 5 to be 6, and then I'm going to add another one, which says first put some strings in, and 2 and 8 should be 10. So now we can see how this gets run. So, Jasmine itself actually comes with a spec runner, which is a HTML page. You refresh it, it runs the test and tells you if it passed. This is just a really simple page. You include the Jasmine library, and then you include your JavaScript and your test, and it simply runs it. And this is okay. It's a bit laborious. You still have to open up in a browser, you still have to open up an alternate browser that you want to support. So it's still not fantastic. So there's another way. The tool called Karma, oops, so over here, so there's a tool called Karma. I've set it up to pull in the same JavaScript, the same test cases. This will actually run in the terminal. You can tell it to use whatever browser you want. In this case we're using Chrome. Don't know why it's run 4 times, but we can ignore that. So it runs in your terminal, which is cool. What's even nicer about this is I can actually go in and change my JavaScript. So I'm just going to delete this. We know this will break the code, we saw that before when manually testing. When I save this, it will now automatically run again, and it will tell me the JavaScript's failed, which is really nice. So you can have this ticking away in the background. As you make changes to your JavaScript, you can easily see if it's failed or passed. You can also use it for test-driven development. You can write the test first, and then write your JavaScript until the test passes. So that's really unit testing. Next up is functional testing. So this is used to test the interactions of a user to make sure all the clicks, all the form submissions, that type of stuff is working as it should. Again, several frameworks available. So there's Cucumber, which we use a lot at Expedia. It's a Ruby-based framework. There's Nightwatch.js, which is a Node-based framework. And then there's FuncUnit, which is again JavaScript, but it runs directly in the browser rather than in a separate server-like node. When we look at Nightwatch today, I think it will be most useful to most people. Oops. So I've got this little app that I've made, a little web page. It uses the add number function, simply adds 2 numbers together. Nothing too complex. Again, we can manually test it in all the different browsers that we support. Could get a little bit laborious, especially all the different mobile devices that we support nowadays. Or we could write an automated test. So Nightwatch, again, it's just JavaScript. So you write your test function. When you're writing that, when Nightwatch calls this, it passes through this browser object, which is just an object containing Nightwatch API, and lets you control the browser. So first we're going to load the URL, we're going to wait for the body to load, and then we're going to fill the form in like we did as a user. So we're going to set the value to the 2 inputs, and we're going to click submit button. This is all the user interaction that we want to test, so now we need to make sure that the result of this user interaction is as we expect. And we can do that with this, so we can get the text from the results element, and then see if the value of that equals total 30. If it does, the test will pass. If it doesn't, the test will fail. Again, you can see that actually run. Let me show you the test first. So I've actually split the test up a little bit, just to make it a bit easier to read. So we have a step to load the URL. We then have a step to do the test I've just explained. Now we're running a second test, which actually clears the inputs and ensures that this total gets updated if a user does it twice. So let's see that run. So you simply run that called Nightwatch. You'll see it open up Firefox. Really quick, I'm going to do that again because you missed it. Fills in the form, it submits it, it checks the results, and you know where you're at. You can set this up to run against any browsers you want. You can use remote browser services like BrowserStack or Source Labs, and you can run against that, so you don't need all the browsers locally. So it lets you speed up your testing significantly. Let's see what happens if it fails. So I'm just going to get rid of this label. this is input. Oops, let me try saving it. Yes, notice the test fails, it can't find the input, so we know we've broken something. Fix that, spin it one more time. Now it's passed. That's really all there is to functional testing. You might have more complex interactions. As your application, your website grows, you can add more and more tests. Okay, so we now know that JavaScript is all good. Every time we make a change, we know JavaScript will be fine. Every time we make any change to HTML or JavaScript, we know the user interactions will be fine. But what we don't know is if we mess up the CSS somehow, all those tests can pass absolutely fine, and yet the user experience can still be broken. And that's where visual regression tests come in. Again, there's different frameworks available. So we use Phantom CSS in the client-side engineering team, but there are several others available too. So I'll tell you a little story about why we actually added visual tests. So about 3 or so years ago, we had to update a button. On the face of it, it was a really simple update. It's just changing some of the styles. I think it was making sure the icon worked correctly. All was good. We tested it thoroughly. We tested it across all the different browsers manually, all the different devices that we support, and it all looked absolutely fine. So we shipped it. I don't think it went live, but we pushed it so teams could start using it. And then teams started contacting us and going, have you updated the calendar module? No, I don't think so. Let me take a look. And then we found an issue. So while updating what we thought was just the yellow button, we've actually updated these buttons too. Now this showed 2 things. One, our CSS probably wasn't structured as well as it could have been. But 2, we had to stop this in the future. Our library, our toolkit was too big at that stage to test everything manually. So we needed an automated way of doing it. And that's where Phantom CSS came in. So Phantom CSS is a module for Casper.js, which is a sort of testing library for Phantom.js. For those who know, Phantom.js is a headless browser. It's based on WebKit. Because it's headless, you can run tests much quicker normally than you could on a real browser, should we say. So the way Phantom CSS works is when you first run your test suite, it will take a base image. And this is kind of the source of truth. This is what your image should look like. This is what your site should look like. So these should all get pushed to GitHub, or wherever your code lives, and sit alongside your code. Second time Phantom CSS runs, so when you make a change and you run it again, it will create a second image. You can spot there's a few differences here. Phantom CSS also knows this, so it creates a failed image, which shows the difference between the two. And you now instantly know you've got an issue, and you can go and fix it. So again, these tests are written in JavaScript. Similar to Nightwatch really, so you open your URL, we're setting the viewport size. We're then calling Phantom CSS to take a screenshot of the section with the ID add numbers, and we're calling it add numbers. You can do as many of these screenshots as you want. You can do more complex interactions before taking a screenshot. We'll see that in a little second. And then once you've gotten all your screenshots, you call Phantom compare all, and this will take all the screenshots it's just taken and compare them to your base images. So we can see that practice. So this is the test suite which we're going to run. This is a little bit of setup for Phantom CSS. Here's our actual test. So we open the URL. This is the one we just looked at. I've added a second test. This actually fills out the form and then submits the form and then takes a screenshot. So we can see the before and after submission. And we're comparing all and we're ending it. Let's see that in action. Test suite, we'll just call that. Okay, so what we can see here is we've got 2 new screenshots saying this must be your first time running them. So what it's done is created those base screenshots for us. And we can take a look at those. So that's the first one, that's before the submission, and we've got after the submission. We've checked those, we know they look good, so we can now submit those with our change. Next time someone runs them, we haven't made any changes, so we'd expect this to pass. And they do, which is good. So if we make a change now, so I'm just going to change the margin for the labels. If we run this again, we should expect this to fail, because the screenshot should have changed. And they have. So we've got 2 failures, so we can go and look at the images to see how they failed. So we've still got our base image, that's still the same. We've now got this diff image, and we can tell that is different. So Phantom has created a failed image, which points out what the differences are. And then it's the same with the submitted ones as well. So now that we know it's broken, so we can now go back, we can fix it. That should all pass again. So we're all good, so we've all fixed it. Now, there are a few things you need to keep in mind when doing visual testing. First is to avoid taking a screenshot of the whole page. I think this is very tempting to do, but it does have some negatives associated with it. First off, if you take a picture of the whole screen, it's such a big image, it will take a long time to process. When doing the comparison, it's literally going pixel by pixel through the image and comparing them. So the more pixels there are, the longer it's going to take. But on top of that, if you've got a big image and something changes, it has a tendency of knocking the whole image out of sync. So it's very hard to tell what's actually broken. If you break your page down into smaller modules, and one of those fails, you know exactly what's failed. On the flip side, you don't want to break your page up too much, so it's a bit of a balancing act. We had a situation where we were testing the icon set within inside the UI Toolkit. We have 100 different icons. We test everything on 4 different screen sizes to represent mobile, small tablet, big tablet, and desktop. So we were just doing 400 tests just to test icons, and it was taking about 20 minutes. So we went back to the drawing board, and we actually grouped all the icons together, and we now take a single screenshot of all the icons, the 4 different breakpoints, so we have 4 tests, and now it takes a few seconds. So it's a bit of a balancing act. You need to play around to see what works best for your web page. Testing takes quite a while to run, I just said that. So you really have to consider when you want to run them. Do you want to run them on every commit? Do you want to run them on every release? Kind of up to you. Where do you want to run? Do you want to run them on your dev machine, or do you want to run them on a test server somewhere? I'd probably suggest a test server somewhere. Especially when you consider this 4th reason, which is tests have to be run on the same OS, straight machine type, otherwise you run into issues. Because different OSs have different fonts and different colour palettes. If you take a base image on a Mac and then try and run the tests in Windows, they won't match. So if you have a test box, you can guarantee it's always going to be the same OS machine type. Okay, so we now know that our JavaScript's working, we know that the website is functional to the majority of people, we know it looks right, but what we don't know is if it's actually accessible to all people. People using assistive technology such as screen readers, or people who have to use the keyboard because they haven't got a choice. And that's where accessibility testing comes in. Again, there's a bunch of frameworks available. So we use Axe, but there's also these other 2 called Pally and Ali. You'll see this alley word come up quite a lot. It's actually A11Y, so it's short for accessibility. But yeah, we use Axe, so let's have a look at Axe. What does Axe check? So Axe checks the colour contrast for you, so it makes sure that your text has enough colour contrast with the background of your web page, so that it's readable to as many people as possible. Checks that form elements have labels. This is really important for screen readers because without a label, there's no way for someone using screen readers to know what that form element's for. Checks that images have alternative text for exactly the same reason. Screen readers need this to describe what an image is to a user. One thing I would say, so Axe will check that an image has alternative text. What it can't do is check that that text is actually suitable for that image. So you still have to do a bit of manual testing there. Checks that ARIA roles and landmarks are used correctly. So these are used to add more context to your web page for screen readers again. And finally, we'll check that tables are correctly structured. Again, really important for screen readers. So how do we set up? How do we run Axe? So Axe has really two options. It's got a Chrome DevTool, DevTool extension, should I say, which we're going to look at. And you can also run it automatically. When we say automatically, Axe actually ties in to other testing frameworks. So it's not you can't run it automatically by itself, you have to use another testing framework to run it. But we really see it as kind of functional test, so we tie it in with our functional testing. So that's what we're going to do today with Nightwatch. It's quite simple to do. If you add this script to your page, ensuring it only gets added when you run your test. You don't want it in production, you don't want your user downloading an extra script. And then in your test suite, you can run this bit of JavaScript on your page. This will generate some results, which will have an array of pass tests and an array of failed tests. And then you can choose to do something with that. So let's take a look. So we're going to add it to our Nightwatch. Similar to before, we're opening the browser, loading this URL, waiting for the body to load. When calling this JavaScript on the page using this async, sexy async function, once Axe has run its tests, it calls this function. What this function does is it looks for the results, sees how many violations there are, how many failures there are. We count them. If there's more than 0, we generate some error messaging. Within this violations, within each violation, there's a bit of help text which basically explains how to fix the issue. So we've added that into our message. And then finally do a test. And this is basically saying, if this is true, then we're good. If it's false, then we're not good. So let's run that. That's interesting. Okay. It seems like my keyboard doesn't like terminal anymore. I can't type into it. Interesting. I love live demos. Yeah, it looks like. There we go. It's caught up with itself. Okay. Yeah, so if you run this, so first we'll run the test we had before, and we're now running accessibility tests. So we've got a failure, so it says form elements must have labels. So let's go and look at our HTML. Actually, let's go and look at the actual page. I've only got 2 form elements, so it's quite easy to find out which one will have a label. I want to show you the Chrome Developer tool. So this runs exactly the same tests. You click Analyze, it will analyze the page. So yeah, so form elements must have labels. Tells you exactly which form element it is, and then you can click inspect, and it'll actually jump to it as well. So you can see we're using a span instead of a label. Let's go and fix that. If we run our tests once more, we should all pass. Start running accessibility tests. So we now got a pass, so we know all is good. I'm going to do a shameless plug for our next talk. If you want to know more about accessibility, Jack, who's stood over there, is going to be doing a talk on the 10th of August, same time, same place, a talk about accessibility. But you can see more details on our events page. So that's really all the testing, automated testing that we do. I think it allows us to catch bugs earlier, which is great, obviously. The earlier you catch the bugs, the sooner you can fix it. If you can do it before it goes live, it saves a lot of headaches. Saves a lot of time manually testing. Doesn't completely eliminate manual testing. The way we generally look at it is we will manually test the change that we've done and then use our automated test to regression test everything else. And it gives us more confidence to make changes. These could be big changes such as changing the JavaScript library, which affects your whole code base. If you've got tests in place, you can run those and you know you're good. A common question that comes up is how much testing should you do? I've got a bit of a cop-out answer. As much as you need. Really depends on your project. I think if we're doing a lot of testing because we're relied upon by a lot of people. If we break something, you can break a lot of things. But if you're just doing a JavaScript API, then obviously you just need unit tests. If you're just writing HTML and CSS, then visual tests or functional tests will probably be fine. And that is it. I've got some resources. So we're going to share these slides out. So yeah, if you want to look at more to what we've talked about, a bunch of URLs there to help you. And that is it. So thank you.